Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we were studied the various types of SFRs of 8051 microcontroller, the reset and the clock circuit of the 8051 microcontroller, and also in previous video we learned that what is meant by machine cycle and state of the clock. The link of the previous video is available in the description box. Please check it. In this video, we are going to see the external memory interfacing with 8051 microcontroller. When the internal memories of the microcontroller are not sufficient, then the external memory is needed. As the PC of 8051 microcontroller is 16-bit, it is capable of addressing 64 kilobytes external memory. Now, before going to see the actual interfacing of the memory to the 8051 microcontroller, let's summarize the some important points. We know that this is the pin diagram of 8051 microcontroller, and these three pins are used in the case of external memory interfacing. Now let's see once again the function of these pins. The first pin is EA pin. We know that the EA word stands for external access pin, and this pin is of active low type because a bar is placed overhead of the EA word. The EA pin must be connected either to VCC or either to ground. It cannot be left unconnected. Hence, let's see the points about the EA pin. In the case of external memory interfacing, connect EA pin to the ground. Normally, it is connected to the VCC. Let's see, when we interface an external memory to the microcontroller, this EA pin must be connected to ground. But when we use the internal memory of 8051 microcontroller, the EA pin is connected to VCC. I hope you understand the function of EA pin. EA pin is must connected to the ground in the case of external memory interfacing. Our next pin is PSEN pin. The PSEN word stands for Program Store Enable pin. It is also an active low type of pin. In the case of external memory interfacing, connect the PSEN pin to the OE pin, that means output enable pin, and chip enable pin of the external memories. That means when we use the external memory, then the EA pin must be connected to the ground and the PSEN pin must be connected to the output enable pin of the external memory. I hope you all understand the function of EA pin and the PSEN pin. Now our next point is the port P0 and P1 provides the 16-bit address to the external memory. We know that 8051 microcontroller has the 16-bit address bus. This 16-bit address is divided into two ports, port P0 and port P2, where port P0 provides the lower 8-bit address A0 to A7. Here port P0 provides the lower address A0 to A7 and port P2 provides higher 8-bit addresses A8 to A15. A8 to A15. We know that port P0 is also used to provide the 8-bit data bus D0 to D7. Here is AD0 is written, that means A stands for address and D stands for data. That means the port P0 is also used to provide the data bus from D0 to D7. The ALE pin. The ALE stands for Address Latch Enable Pin. The ALE pin is used to demultiplex address and data from port P0. Here the AD0 to AD7 is written, that means port P0 provides both address and data. But to demultiplex this address and data, the ALE pin is used. When ALE is equal to 1, port P0 provides address, that means address from A0 to A7, and when ALE is equal to 0, port P0 provides data from D0 to D7. I hope you all understand the basic function of ALE pin. Now let's see the two more important pins in 8051 microcontroller, which are named as WR bar and RD bar, which is in the port 3. The WR bar means the write pin and RD bar pin means the read pin. Okay, if we want to store data into external memory, then we use this WR bar pin, and if we want to take data from the external memory, then we use this RD bar pin. Now let's start the interfacing. Here is the diagram of interfacing 8051 microcontroller with external program ROM is shown. First of all, we have to know that what is meant by program ROM. We know that ROM is the type of memory in which we can only read data, we cannot write data into it. Okay, and the program ROM means in this type of ROM we can store the program instructions. Okay, here let's see the connections of this diagram. Here is the 8051 microcontroller is shown, and here is the 8K by 8 program ROM is shown. Here 8K stands for 8 kilobytes of memory. 8K stands for 8 kilobytes of memory. If we simplify this, then 8 into K means in digital electronics, a K means kilo, and it is of value 1024 bytes. Okay, now the 8 into 1024, this multiplication gives the result 8192 bytes. Okay, there are total 8192 bytes in this program ROM, and if we represent this number in the power of 2, then we get 2 raised to 13. The value of 2 raised to 13 is 8192. Hence we get the 13 address lines. Okay, I hope you all understand the concept. Now this type of interfacing needs 13 address lines. We know that the port P0 gives the lower address from A0 to A7, and the port P2 gives the higher address from A8 to A15. Here are the 8 address lines, and we require total 13 address lines. Hence the remaining 5 lines are taken from the port 2. Hence the address lines are A8 to A12. I hope you all understand the concept of the address lines. How much of address lines are required in 8K by 8 program ROM? The answer is that 13 address lines are required. while 8 are taken from the port P0 and 5 pins are taken from the port P2. The address lines A13, A14 and A15 are not used in this type of interfacing. Okay, now let's see the one by one details about this diagram. Here is the EA pin is connected to ground. This is the very important that in the case of external memory interfacing, the EA pin must be connected to ground. The next point is the PSEN pin. The PSEN pin is connected to the chip enable and output enable pin of the external memory. Okay, now we already seen that the 5 lines from the port P2 are A8 to A12 are used for the higher addresses. It is directly connected to the program ROM because it only gives the address, but the port P0 gives both address and data. To demultiplex this address and data, this latch is used, which works on this ALE pin. When the ALE pin is 1, then address is provided to the program ROM, and when this ALE pin is 0, then data is provided to the program ROM. I hope you all understand the basic connections about the interfacing. Now our next type of interfacing is the interfacing of 8051 microcontroller with external data RAM. We know that the RAM is the memory in which we can read and write data. Hence, here is the read and write pins are used. The read pin is connected to the output enable pin of external data RAM, and write pin is connected to the write enable pin of external data RAM. Okay, now let's see, this part is similar to the previous diagram. Okay, what is the function of this part? Here is the port P0 is given, the latch is given to the demultiplex address and data, which is based on this ALE pin. Okay, now the 5 address pins are given by port P2 and the remaining 3 pins A13, A14 and A15 are given to the chip enable pin by a NAND gate. Okay, in this case of interfacing, the PSEN pin is left unconnected. The EA pin must be connected to the ground. Okay, I hope you all understand the two interfacing. In first type of interfacing, the PSEN pin is connected to the OE and CE pin, while RD pins and WR pins are left unconnected because we use here the program ROM. We know that the ROM is the memory in which we can only read data. Hence, there is no need to write data or read data. There is only PSEN connect to directly output enable and chip enable pin. And in second type, the RD here is memory used RAM memory. Hence, the RD pin is connected to the output enable pin, write pin is connected to the write enable pin, and the remaining 3 lines are used for the chip enable pin. Okay, now let's see the third type of interfacing. interfacing of 8051 microcontroller with external data ROM. Here is the external data ROM. Means in this type of ROM we can only read the data. Hence this read pin is connected to the output enable pin, while the write operation is not allowed in this type of ROM. Hence this pin is left unconnected. Also the PSEN pin is also left unconnected. The other pins are connected similar, that means EA is connected to ground. The latch is used to demultiplex address and data. When ALE equal to 1, it gives address. When ALE equal to 0, it gives data. The 5 address lines are connected and the 3 lines are used for the chip enable pin. That means if we look carefully at the 3 diagram, then we can notice that in all the 3 diagrams some part is similar. That means here the EA pin is always connected to ground, second type, and in third type also the EA pin is connected to ground. Now let's see, this part is also similar. This part is also similar. Okay, in this diagram also this part is similar. Okay, now the main difference is about the 3 pins. Which are they? The 3 pins are RD, write, and PSEN. In the case of program ROM, the PSEN pin must be connected to the output enable pin and chip enable pin, while these 2 pins are left unconnected. In the case of external data RAM, the RD pin is connected to the output enable pin, write pin is connected to the write enable pin, and these 3 pins are connected to the chip enable pin through the NAND gate, and while the PSEN pin is left unconnected. And in the case of the external data ROM, the read pin is connected to the output enable pin, write pin and PSEN pin are left unconnected, and the 3 pins, that means the 3 address pins A13 to A15 are used to chip enable by a NAND gate. I hope you all understand the basic differences and the interfacing of the external memories to the 8051 microcontroller. Thank you, students.